Imagine this. 50% of all the software you use in your company has a vulnerability. And we learned this overnight. What would you do? Well, in fact, this already happened. And we call this Log4j. And that's the subject of today. Thank you for joining. And my name is Leeuw Jan Koning. And from the Security Operations Center floor here at Ontoit, we bring you Threat Talks, the deep dive. And today's subject is supply chain attacks, Log4j. So let's get onto it. Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity. Let me first introduce my two guests of today. First of all, Rob Maas, welcome. He is the field CTO of Ontoit, and his job is to make sure that all our customers are really safe and applying all the security measures in a proper way. And on my other side, it's Luca Cipriano. He's a threat intel specialist at Ontoit, and he's a very technical person, but he is also capable of explaining those very technical things to us, and that's what we can use in a deep dive like this. First of all, Luca, we're talking about Log4j. It's also known as Log4j. In a nutshell, what's it about?
So basically, it's a vulnerability that was present in a open source library, which is called Log4j.
Aha. Okay, and so it was widely open on the internet, and a library means that if I'm using software, it's a Java library?
Yes, it was a Java library, and basically it is a component of, let's say, for example, a Java program that you use for, can be any reason. In this case, this one was a component that was used for logging. You know, when you have developers, they maybe want to log errors, they want to log requests, all these kind of things. So
everybody needs it. It's like
everybody
commodity.
needs logs. Yes,
and therefore,
logs.
Most Java programs actually is a very popular library. Huh?
Yeah, and therefore, like being open source, it was really widely distributed and used in a lot of software servers. And
typical case of supply chain attacks, right, Rob?
Yeah. This is a nice example. It's slightly different than we had on the SolarWinds attack, where it was on purpose, where a vulnerability was basically planted in the software. In this case, it's a library where hopefully accidentally some code was written that was not completely secure, but used by a lot of companies, and that made the impact quite big.
Before we dive into everything that happened and what investigations need to be done and how it actually works, I mean, it's open source. It's been on GitHub probably, been there for a while, I guess. Why did nobody spot the error?
That's a very good question, and we can only assume why that didn't happen. But probably there are a lot of lines of code, so it's hard, of course, to go over all the lines of code and check if you can spot basically an error or that can lead to a vulnerability. That's one reason. I think the other reason is probably also this package started very small, and if you start a new software project and then you don't have many people basically checking your software until it's used by a lot of other people, and then if you propose a change, everyone is going to check, hey, is that change going to break my implementation? And hopefully also check for the vulnerabilities that can come with it.
Yeah, we all publish some software online somewhere probably. How does that work? Your quality control, if you may. You've built components that we use ourselves and for our customers, right, Rob?
Yeah, that's correct. Yeah, so there are different ways, but especially in the open source community, it's what you then do basically is create a merge request or a pull request, depending a bit on the systems you use. So you propose, as you say, okay, I've made some improvements in your software. And then you say, okay, here's my pull request. So could you please check this and then merge it with your project? And then it basically becomes mainstream and it's embedded.
Someone approved it. Nobody checked it. Why did nobody check it? Why didn't you check it?
Why didn't you check it? Huh? Why? Like, why nobody checked it? Yeah, well, I guess we don't know. Nobody checked. And actually also Java has really backwards compatibility is one of the main things. So to avoid breaking things, they try to never remove parts. So it's always carried on components. So, well, it was living there. We didn't check.
Yeah, we're still humans, so maybe it was checked but still missed.
Yeah,
I don't know how many lines of code are available online. I mean, there's a lot of lines per inhabitant of the earth probably to check, right?
Yeah, exactly. I think it's easy to miss us there. Yeah.
It's a fact of life that whenever you use code, whether you write it yourself or it's publicly available for years already, widely used, still it can
Yeah, but it's probably better checked than a lot of closed source. components.
Yeah, of course, because
always
there's
a nice
more people looking at it. It's the pro and the con. Like, well, if you don't publish your code, well, you have less people, that are able to check it.
Yeah.
So
Okay. So what was this all about? What kind of thing happened here? What was in this library?
So it all started with a video game, like sometimes it happens, like Minecraft. So was December 2021. I still have nightmares about that. It had a really big impact. But basically, some player of Minecraft realized that just typing a string on the chat or changing for example, the username of their account, they could trigger remote code execution or eventually denial of service, and it was used there. Then basically, of course, at the beginning it started with just Minecraft, but then we all realized that this library is used everywhere, and we saw it in Minecraft in the chat, for example, because they were logging chats, so that was ending in the logs of the chat.
So you would just type something in the chat of Minecraft, and then it would be fed into this library.
It will be fed because this.
And if you had a specially crafted string,
if you have a specially crafted string, you can make it do things. So like what happened, for example, in this case, is the problem is that this specific library allows for JNDI lookups. So basically,
please explain.
Yes. So Java naming and directory interface. Basically, it allows to include something in the logs that is stored somewhere else. So it allows from the logs to do a call and just add something that is not there in the log at the time.
Like a macro.
Similar to a macro, yes. And basically, it can have, it can be useful for troubleshooting or for, developers. The problem is that if you don't sanitize the message that you can store, then you can, allow this kind of things to happen. In this specific case, somebody could craft a string initiating an LDAP or an RMI, call outside, and they could specify the target address of where the server needed to connect to retrieve that part of the logs that was not there.
We tried this actually, by changing the name of an iPhone, the host name of an iPhone, into this specially crafted string, and it would actually do a DNS lookup into our DNS server. So apparently,
it was so widely distributed it basically affected everybody, like almost all the companies. Like there were like softwares or companies that probably didn't even know that they were using it because it was just there. So remote code execution was not the only problem here. It's because like this library then allows also to resolve environmental variable. So, for example, if I would craft an LDAP request to my malicious server and I will add in the path, for example, I don't know, $, something like a secret key or that you have maybe from your AWS server, then it will resolve that environmental variable and send the call to the attacker, me, with that basically value that is stored.
So let me get this right. So I'm putting in a string, and the string actually on the server. So maybe say it's a container where it's getting interpreted. For example, in my Minecraft chat or my iPhone name or wherever it is, and then it leads into a special interpreter setting up a connection to somewhere else, to, for example, a host name, which will then resolve its DNS, for example.
Yes.
But it can also, if there's an environment variable, which is typically the case in containers, right, like a database password or so, it could then make it as part of basically that request, either resolve it or even the next step.
Well, resolve it and add it, and then maybe I have my server, and you're trying to connect to my malicious server / your variable, and then I will.
Then you have it in your logs
because I have it in my logs, and I can see what is your variable in that case. That's an example for you.
If you would use in your server Log4j as a logging system,
then we ping pong.
Could do it double, yeah.
So, yes, basically the impact was huge, was really broad. Luckily, there were not it didn't lead to massive leaks or something like that. But fun thing, nowadays, there are still attempts to exploit this
It's been a
vulnerability.
recent rise, huh? Why?
Yes. Well, of course, attackers try everything as well. When we look at those numbers, we need to also remember that they include honeypots, for example. So that's possible that maybe some researchers started to set up more honeypots with this vulnerability, and then of course you have automatic scan, and then of course you see an increase in that as well. That can happen. But yeah, apparently some people also, they're still running vulnerable libraries.
Yeah. Rob, I mean, he said there's going to be DNS requests that may contain sensitive information. And there's also going to be LDAP connections going out. Huh?
Yeah, so the idea is basically that if you put in an LDAP string, so that it needs to connect to an LDAP server, you can use that basically as your mechanism to distribute your payload. So as an attacker, you can set up an LDAP server and then host the payload, and then inject basically the string pointing at your LDAP server. And if the logging server is then allowed to go connect to your LDAP server, you can potentially send the payload back into the Log4j.
Yeah, and that's what my question is about. Yeah. Why would that be possible?
It shouldn't, but it comes back to a discussion we had a couple of times already. A lot of people still looking at the internet for traffic coming in instead of going out. And in this case, it's the traffic, the communication is started from your Log4j component, which is on a server in your internal network, and is going then outside. And that's quite often still the case that is open for everyone, so that it can easily get its updates or whatever it needs to look up. But best practice in this is close all the connections that are not needed for the server.
Yeah, that would mitigate most of this risk then.
Yeah, then the first attempt is hard to prevent until you have patched it. So you can send the string, but then the connection is basically just simply blocked. So then
this is one of the first things in Zero Trust, right? We segment your network and then be in control of your flows.
Yeah, exactly. If you segment your network, so if you say, okay, this is my Java application, then you should precisely know what is allowed and what's not. And normally, if you do that well, it's quite easy to come up with some good policies, and you only have a few of them.
Yeah, and unless you have an access policy that says, from my application to the rest of the world, allow LDAP, which no one will approve.
Well, it's unfortunately, it should not be approved, but people are a bit scared quite often to block things because maybe it impacts a production process or any business process. But that should be the case. So just deny everything except from what you really need.
We had a couple of rough nights here. Huh?
Yes.
So what did we do?
So, first of all, as you mentioned, like this, the basic of Zero Trust. So for all our customers with a good Zero Trust implementation, then it was easier to prevent this or to anyway clean up if there was something still to be cleaned up.
Yeah, so that means they were vulnerable. I mean, that software was installed because everybody had it and there was no patch initially.
It was really difficult to determine where you had it. That's the biggest, that was the biggest challenge.
Yeah, tell me a little bit more about that.
Yes, basically it was so widely distributed, and for example, for some companies they have internal development. Maybe they were using it, they were not aware that it was there, or you use third-party software. Well, then good luck finding out everything that is in your third-party
because
software.
You know it's version 3. I don't remember exactly what it was.
It's a specific version that was vulnerable. Yeah, of course.
But that's the version of the library. That's not necessarily the version of the software.
No, exactly. It's the version of the library. So, and of course, sometimes developers, they don't know it themselves, but also third-party software, you don't have access to that information. And we tried for some of those software to look if we could find if they had it, but well, it's not documented really well, and sometimes not at all. So of course,
but you could see it in a file. I believe there's one particular file that has the code.
Yeah, what we did for our customers that we manage their endpoint detection system, we run queries looking for the specific library that was affected. We had several queries that we could run, and then we tell them, hey, this host, we found it, so please check and patch it or see what it's installed that has this library that is using it. So it was one way to detect it, and that was what we did as well. But also
what we would say is called software bill of materials then.
Sorry?
the software bill of materials,
Yeah.
basically, that you look into and you need to figure out, this component is used here. And then I need to update this particular piece of software.
Yeah.
And go to the
or,
vendor.
Or decide if it's not possible to remove the software because the vendor maybe does not have a patch yet.
Yeah, or simply close the firewall.
Yeah, so closing the firewall, that's also a thing we did for our customers.
We did it,
For all the customers that we saw, hey, LDAP is still allowed or RMI is still allowed. Make strict outgoing policies, of course, without conducting the client if that was an option. But that's the simple mitigation. But then, of course, you also want to patch eventually, because it can also happen inside of your network, especially if you're a larger company. To add to the XDR queries we did to find the file, also the National Cybersecurity Center in the Netherlands released some tools to basically, to quickly scan your network to see if that file was there and if you were vulnerable.
It was a lot of work. It kept us busy quite a lot.
Yeah, but tooling was actually of the essence there.
Yeah,
if you have a solution that can query which files are on all endpoints, and we have that with a lot of customers, fortunately. So then we could quickly find out which software components. Well, it was a big surprise to many customers. Oh, really? Is it all these things? Because where do you start? I mean, are you going to call all your suppliers and say, "Hey, listen, I have version 3.7. Does it include your this? Is it Java based? If yes, did you use this library? If yes, did you use this?"
And also I think that here that was part of also a bit of the supply chain attack, but also not only that. That's the biggest effort was the coordination between all the parties involved, which is us, which is the customer, which is the third party. That's what made it quite difficult.
They say never waste a good crisis, and what I also learned from it is that lots of IT organizations, you couldn't get this policy of being in control of outbound flows, we mentioned, couldn't get it through because of people were fearing downtime, because suddenly there's more being blocked. And to us, it's very natural, of course, that you do that. But we improved a lot of firewall process. Let me put it like that.
Thanks to the attacker, now you're in control.
Again, supply chain attacks have their good moments sometimes.
Yes.
All right. So to wrap up, I think what I've heard is, we can't really avoid these kind of supply chain attacks. We should always be aware of it. What you need to understand, we need to have is a tool to quickly assess, to be able to quickly assess where it is. That's one thing.
Try to keep a software bill of materials. So keep track of what software or libraries you are using. Then at least for everything you do yourself, you should be able to quickly determine if you're affected when Log4j comes out, for example.
Yeah, Log4j. Yeah, looking forward to it. And then of course, segmentation, as always. I mean, make sure you're in control of your flows. That's the basics. Every attack is always over an allow rule.
Outbound connections.
Yes.
Not too many allow rules in your firewall, and not implicit as well. All right, gentlemen, thank you very much.
Thank you.
To our viewers, thank you very much for listening in. This was a deep dive of Threat Talks. We do have a lot of materials available to you. If you go to threat-talks.com, we have them all available. There's infographics, there's material that you can use if you want to make a presentation about this, or for education in your own organization, for example. Feel free to use it and go there. If you liked this podcast and video cast, please like the video. That helps us spread the word better. And if you don't want to miss the next one, press the button for notification. So next time you will get a push notification when one's available. Every week we will ship one. Once every month, that is a more extensive version where we talk about a more non-technical subject. Like last time was the supply chain attack. And then we have a couple of deep dives like this one where we dive a little bit deeper on the specific talk. So that's the cadence that you can expect from us. Thank you very much. From the Security Operations Center floor here at OnToIt, I thank you and hope to see you next time. Thank you for listening to Threat Talks, a podcast by OnToIt Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.